So good day and welcome to my demo video for the hands-on lab 12. Because it consists of shift registers, and first I will just try to introduce shift registers and how is my design connected to that one. So first I'm gonna read shift registers are designed using flip-flops are the devices that stores and transfers the data bits. So, they are basically a type of sequential logic circuit used to store and shift or transfer data bits in either serial or parallel combination. So, they are basically configured using flip-flops in sequence, where the output of one flip-flop becomes the output of another. So, this is a shift register, right? So, we have here the clock and the data input and the output pins. We have 8 output pins here. So, there's schematic diagram. So I'm gonna go ahead to my design first. So as you can see, these are the 7495 shift registers. They are 8-bit and they consist of different pins. So we have 8 output pins, right? The 8 output pins will serve as the output for the LED, and then in my design I will just show how the running lights work. So first I configure the design based on sources. I used this dip switch instead of the IP switch, sorry, instead of the Arduino one, because I thought we were not gonna use it yet. So I have here various connections. I used 5 IC 1 2 3 4 5 2 3 4 5 6 ICs for this design. So as you can see, this is the final output. I have here the 7495 pin, which are connected to these LEDs. I don't know the exact number, but I guess it works here. So as I turn on, I'll try to turn on the design. As you can see, the design runs. It's like a running light. So sorry for the delay. So this is just the initial, it's flowing, right? So when I turn on this number 4 switch right here, it latches a logic 0 to the clock input, making it making the cycle show a logic 0 whenever a next cycle is being produced here. So as you can see, there are gaps between logic 0 and logic 1. This is how you play the shift register to create a pattern of lights right here. So I'm just clicking the force switch right here, so that I will create a pattern of flickering lights. And as you can see, there are alternating lights here that is being stored in this 7495 shift register. So this 3 it represents the reset switch. So it resets the internal memory. All the memory you did are gone, so the LEDs will go back to logic 0. So for the clock input, I used here a function generator. This function generator enables the clock input. So whenever I want to increase the speed, I might increase the frequency right here. So I have here now 40. Let's try for the output. As you can see, the flow is going faster because I increased the frequency. So I'm gonna turn on switch 4 to create a pattern of flickering lights right here. So as you can see, and once I press 0, it latches, it stores 0. So it then reflects in the output. There is a gap between the 0 between the lights. There is a logic 0. This is because I pressed the 4, which serves as the it connected to this input pin right here. It's pin 3, is pin here. So when I don't turn on logic 4, if 4 is just if they don't turn on switch 4, just logic 0, so it's just the design is just turned on, it won't latch, and thus the memory will become just 1 1 1 1 1 all throughout when it simulates the circuit. So when I latch again, as long as I latch, it will send a logic 0, so that become it's stored in the memory and that it's reflected output. And once I press 3 logic 1 switch 3 is logic 1, the output resets. So this is it for my simulation, and thank you for listening.